Welcome to Elimination 1, solving systems of equations using elimination. Elimination is a strategy for solving systems of equations where we use addition and subtraction of the entire equation, both sides, to eliminate one of the variables in a system. This works really well if you have similar coefficients or the same coefficients of the same variable in two different equations. So let's look at this first equation. This first system right here, 4x plus 6y equals 32, 3x minus 6y equals 3. We have 6y and negative 6y, right? And we know that when you add those together, you get 0. So I'm going to simply do that, add them together. And you're just going to add vertically. They have to be, your equations need to be lined up like this. They need to be 4x plus 6y, 3x minus 6y, right? So that the x's and the y's line up, and the constants, those are called constants, on the other side line up as well. So 4x plus 3x is clearly 7x. And then 6y plus negative 6y is 0. 32 plus 3 is 35. So we have 7x equals 35. Look, everybody here should be able to solve this equation, right? We can just divide both sides by 7. And x is indeed 5. Once you have this, once you have one variable, then it's easy to go to the second variable. Pick either one. It doesn't matter which one you pick. I'm going to pick this one down here because it's simpler to me. And just replace x with 5, right? 3 times 5 minus 6y equals 3. Okay, whoa, that was weird. If 3 times 5 minus 6y equals 3, then 15 minus 6y equals 3. That's a minus sign. And then you can subtract 15 from both sides because 15 is positive. And you get negative 6y is equal to negative 12. Divide both sides by negative 6. And y then is equal to 2. So your point, your solution, if you write it as x comma y as an ordered pair, would be 5 comma 2. This is your solution. Does that make sense? So addition and then substitution. Okay, let's do one more example and then we'll stop. In the meantime, I had a question, which is, why couldn't the pony sing? It's because he was a little hoarse. Okay, so this one actually, we do have opposite signs, but I'm going to change up the tactic and I'm going to subtract these because we also have the same coefficients on the y, and I just like getting rid of y's really. And then and I'm going to subtract them because, as we all know, y minus y is 0. And z minus negative z is 2z. Oh, that's a horrible z. Let's try that again. 2z. And then 4 minus 8 is negative 4. Okay? So then we get, that's 0 plus. So that's 2z equals negative 4. Divide by 2. Divide by 2. And z then is negative 2. So then we can plug this back in and say y plus negative 2 equals 4. And then add 2. And y is 6. And then we get, right, this is our ordered pair. I'm not going to write it as an ordered pair because it's not x and y. But this is our solution. You can actually grab this thing right here, boom, and just move it over here. And then you have a lovely little solution. And then we'll just draw a nice little box around it. It's probably green. A green box around the solution. All right, there's your first introduction to elimination. We'll continue in elimination 2.